Look up. The universe is telling you its story. The latest deep field images from NASA's James Webb Telescope have revolutionized the way scientists study the cosmos. From newborn stars in the Carina Nebula to the eternal dance of Stephan's quintet, the images show us a narrow slice of our vast cosmos. So in this video, we're taking a look at NASA's deepest peek into the universe so far. Let's jump right in. First up, the Webb's first deep field image of SMACS 0723. There's nothing quite like seeing ancient history right before your eyes, is it? On Earth, you'd have to go to Italy, Egypt, or Easter Island to get a look at ancient relics. But that's not the case with the cosmos. All you have to do is look up at the clear night sky. A tiny pixel-sized patch of the sky will tell you the secrets of galaxies, the clusters they reside in, and even undiscovered planets. So the James Webb Telescope did exactly that. It pointed its near-infrared camera, or NIRCam, at a teensy tiny little patch in the southern sky. How teensy, you ask? Well, let's quickly put that into perspective, shall we? Let's say you grab a grain of sand and hold it out at an arm's length to the southern sky, somewhere near the constellation Volans. It's probably smaller than a pixel, right? But within that pixel, you'll find thousands of galaxies. Not stars, galaxies. That's why the Webb Deep Field image is so important to astronomers and researchers around the world. In fact, it's such a huge deal that President Joe Biden unveiled the image of SMACS 0723 during a White House event on July 11th. But how did Webb take the picture? And why did it use infrared cameras? Now, here's the catch to viewing stuff far, far away. You can't view it using the color spectrum that we're used to. The galaxies that are the farthest away from us keep moving away from us at a certain speed. It's called expansion, and the universe is going to continue expanding until all the stars and the galaxies that house them have died. So what happens when stuff keeps moving farther away? The light it emits takes longer and longer to reach us, losing some of its energy along the way, and this is called redshifting. The result is light that's been redshifted all the way into the infrared part of the electromagnetic spectrum. So if the Webb telescope used a normal light sensor, it wouldn't have captured much detail, and we wouldn't have had the sharpest and most gorgeous image of SMACS 0723. Webb looked deep into the cosmos, or rather it looked at the grain of sand held at arm's length and kept staring at it for about 12.5 hours. It searched the depths of the galaxy cluster at different wavelengths, and the composite image is more detailed than anything the Hubble Space Telescope has ever come up with. Here's a fun little fact. Whenever Hubble wanted to take a deep field image, it had to look at one patch of the sky for weeks at a time in order to come up with a decent composite. Webb did it in like half a day. That's beyond impressive. And now we have a galaxy cluster as it appeared 4.6 billion years ago. The image is absolutely bonkers. First of all, you'll notice a lot of objects that appear to have spikes, like a sea urchin. Those are stars. Yep, stars appear brighter at shorter wavelengths and show up with prominent diffraction spikes. And then you look at the rest of the image, and you can see obvious galaxies and smears and dots. But let's talk about the dots for a second, because that's got us totally excited. Pick any dot on the image, any dot at all. That's a galaxy filled with billions of stars. Yep, every single dot is an entire galaxy, and there are thousands of galaxies in that photo. Now the smears. Some objects look dwarfed, right? Like a finger smeared a drop of milk all over a piece of black cloth. Well, here's the thing. Those are galaxies too, but they're behind the SMACS 0723 cluster. A galaxy cluster has an enormous gravitational field, and light from distant objects behind the cluster can bend around it in order to reach us. It's the same way a magnifying glass warps objects in front of it. Kind of reminds you of Interstellar, right? When Cooper and Brand get closer and closer to the black hole, it's totally like that. But we've got much more to learn about the cluster in the coming weeks and months. Researchers have already started digging into Webb's data, so maybe we'll learn about aliens or megastructures in the ancient universe. Well, that's unlikely, but we will learn more about how stars are born and how the baby universe behaved. Wait, did we say baby universe? Yep, a baby universe, within a billion or so years old. That's not a baby in human years, but in the vast cosmic universe, a billion years is literally a blink of an eye. Webb's image is basically a peephole that lets us look back in time. What we're looking at is a universe just after the Big Bang, teeming with young, energetic galaxies, and researchers are going to decipher their stories. With the data collected by Webb's telescope, they'll be able to figure out the galaxies' masses, compositions, and more importantly, how they eventually stop producing stars when they grow older. Now, let's look at the eternal dance of Stephan's quintet. It's a group of 5 galaxies caught in an eternal dance, set on a crash course towards each other. Actually, only 4 of them are close together and caught up in a cosmic ballet. The 5th one is closer to Earth than it is to the other 4, but the image is nonetheless mesmerizing. It shows never-before-seen details of the quintet, with sweeping tails of dust and gas. You can also see stars literally being pulled from several of the galaxies due to intense gravitational interactions. Webb even captured the shock waves of one of the galaxies smashing into the other, making them both swirl like milk in coffee. What makes the new image so groundbreaking is that it's the largest image Webb has created yet. It has over 150 million pixels and was constructed from about 1,000 separate images. If you want to look at the entire image in one go, Just make a small prayer for your CPU before you do. Oh, and how could we forget? A star's final performance. While it isn't ballet, it truly is a star's final act before dying. The Southern Ring Nebula is about 2,500 light-years away from us, but the distance doesn't hinder its beauty. And one interesting fact about this gorgeous object is that it has two stars locked in a tight orbit around each other. The dimmer of the two has been sending out waves of dust and gas in all directions for thousands of years, but the other, much brighter star helped shape the nebula's appearance. Due to their tight orbits around each other, the two stars do a sort of dance around each other, stirring the pod and creating the asymmetrical patterns we see in Webb's image. Now, if you look closer at Webb's near-infrared image, you'll see that the nebula has layers. Peel back each layer and you'll figure out the nebula's history. The first layer on the outer edge is the shell that the star ejected earlier, and the layers closest to it are the ones it ejected most recently. Researchers trace these layers all the way back to their origin, and that's how they figure out the system's history. Plus, it's absolutely gorgeous to look at. But there's a grand finale from Webb's deep field, and it's arguably the prettiest cosmic structure we've seen yet. Finally, Webb's grand finale, the Carina Nebula. It's 7,500 light-years away from us, and it looks like a glittering cliff that leads into a cosmic sea of stars. When you compare it to Hubble's composite image, you realize just how far technology has come in the last 20 years. Don't get us wrong, Hubble's image was a jaw-dropper, but Webb's image of the Carina Nebula takes the cake and eats it too. From our perspective, it looks like you're watching a cosmic mountain range and a starry sky above it. And if you think of it like a mountain, then get this. The tallest peaks are about 7 light-years high. Now, astronomers call nebulas the stellar nurseries that birth new stars. If you look at the visible light spectrum, you wouldn't be able to see these stellar nurseries. But because Webb's telescope has an extremely sensitive near-infrared cam, it's able to see through the dense cosmic dust. Stars are highly elusive to photograph or even look at in the earliest phase of formation. It's a messy, violent, and rapid event, but Webb's spatial resolution and marvelous imaging capability let researchers peek at one of the grandest events in the early universe. And this is just the beginning. Imagine what you could do if you let the Webb telescope stare at a patch of space for more than 12.5 hours. What would we see? Well, NASA's researchers are going to do just that. The James Webb Deep Field is just the beginning of something much larger. We'll probably be seeing even deeper field images that let us glance at the universe in a way we've never done before. We'll probably see galaxies that were born a few 100 million years after the Big Bang, or maybe a glimpse of the Big Bang itself. And that's a wrap. Thanks for watching. Till next time.